The projectile that we are given. A stone is thrown at a velocity of 38 meters per second at an angle of 20 degrees to the horizontal. Calculate the following. Now, calculate the following. The maximum height that the stone reaches, the horizontal displacement. Now, in calculating the maximum height, this is the formula that we'll be using to calculate. It is h max equals to u squared sine squared x divided by 2g. Then for L max would be u squared sine 2x divided by g. In this case, I will be using gravitational force as 9,81. But you need to read the given instructions carefully so as to see if they want you to use the gravitational force as 9,8 or 9,81. All right. We are given the initial velocity. It is 38 meters per second. Then the angle of projection, it will be the angle of projection. It is 20 degrees. Right now, in calculating the h max, it will be 38 squared multiplied by sine. Now, sine squared x or sine squared theta, you can repeat it twice. If you don't know how to compute it in your calculator, you can repeat it twice and say sine 20 multiplied by sine 20 divide by 2 times 9,81. Okay. If you were to compute it in your calculator, it will be you have to say open bracket sine 20 close bracket squared. If you were to compute it in your calculator, this is the route that you need to take. Right. Then for L max, I'm having 38 sine. Now, this is your double angle. It is your 2x. Now, it is your double angles. It will be 20 multiplied by 2. It is 40. Then we are having sine 40 divided by 9,81 equals to, our height would be 38 squared. It will be 38 squared multiplied by sine 20 multiplied by sine 20. Like I said, if you don't know how to, you might as well repeat it twice. 2 times 9,81. And then I get my height as 8,609 meters. Then in calculating the horizontal displacement, it will be 38 squared. It will be 38 squared multiplied by 38 squared multiplied by sine 40 divided by 9,81. Now I get my answer as 94,616 meters, and of which it makes sense based on the given angle. It makes sense because we said it that for us to be able to get the greatest height, the angle of projection, it has to be 45 degrees to 90 degrees. Then we'll get the greatest height. But if we were to get the greatest displacement, the angle of projection, it has to be from 45 to 0 degrees. Then we'll cover the greatest range. But for greatest height, it has to be height 45 degrees to 90. And for range, the angle of projection, it has to be 45 degrees to 0 degrees. Then we'll cover the greatest range there. All right. Now, this is how you tackle this question. Now, let us look at the second question here. The second question, it is your relative motion. We are given An aircraft of A departs from Lanseria International Airport in a northerly direction. What is it that we know about the northerly direction? We know that it is the direction from north to south. Now you then have to make your projection. This would be your north, east, south, west. Now it is from north to south. North to south. VA. At what speed? 280 kilometers per hour. Then we are told that another aircraft B departs simultaneously from OR Tambo International. Now, in this case, it won't be the question of departing from the same place, but it will be the question of time, departing the same time, simultaneously. Now, when you project it, you will project it on the same Cartesian plate. Okay, same Cartesian plane. Now, the second airplane, we are told that it departs simultaneously from OR Tambo International Airport at an airspeed of 600 kilometers per hour in the direction west. West, it is your reference point, and the angle of projection, it is 60. Now, I'm having VP, it is 600 kilometers per hour. The angle, 60, then this would be 30. They are saying calculate the velocity of craft A relative to. Now, if you are given this statement, you know that you have to keep A in its position and reverse what? VB. When we reverse VB, it will be the opposite direction. Now, this would be 60, that would be 30. Now, this is what we have here. In determining the position of your resultant, we said it that we don't assume. We must always work out the position of our resultant using what? The parallelogram principle. Then, in using the parallel principle, we'll then be able to establish head-to-head and tail-to-tail principle. Then that's where our position of resultant would be. Parallelogram says two sides must be the same and equal in magnitude and direction. This side, it is the same and equal with that one. This one, it is the same and equal with that. It's heading south. This one as well, it must be heading what? South. Now, this is where your resultant would be. Head to head, opposite, it is tail to tail. Now, let's write it nicely because it looks as if the resultant is on the, what's that? It's on the fourth quad. Let's write it nicely. It looks as if it's on the fourth quad, but let's write it nicely. Okay, we are going there, going there. Uh, if it was up to scalar, but for now it is not up to scalar. That one is, this one is heading opposite direction. Then this is what we have. Yes. Right, then we'll denote this is my A, that is my B, that is my C. Head to head, the opposite, it is through tail to tail. We are looking for small b. This would be my A. That would be my C. My A is 280. Then this angle, it is opposite to that angle. This angle, it is 30. You are having alternating angles here. This angle alternates with that one. It means there it is what? It is 30. The angle there, it is what? 30. We'll then be using cosine rule to determine our resultant. We are having b equals to a squared plus c squared minus 2ac cos beta. We have already established this angle, it is 30. Then it will be our a, it is 280 squared plus 600 squared minus 2 times 280 times 600 times cos 30. All square root, then our answer would be 280 squared plus 600 squared minus open bracket 2 times 280 times 600 times cos 30. I get my answer as 383,947 kilometers per hour. All right. This is how we calculate our magnitude. Then in calculating the direction, we'll be using the sine rule. The sine rule, we are determining the big A. That means it will be big A equals to the inverse of sine A sine B over small b. The inverse of sine, our A is 280 multiplied by sine 30 divided by 383,947. Then my angle would be the inverse of sine 280 multiplied by sine 30 divided by 383,947. Boom. I get my angle as 21. But don't forget, it is 21,385 degrees. Now, let's write this nicely so. Let's write it somewhere here. This is what we have there. This is what we have there. We are having the resultant. Then we are having your vector, the one that we've stopped and reversed. Okay? Now, the angle from here to there, it is what? It is 60. The angle from there to there, it is what? It is angle 60. But this is where our resultant has occurred. The angle that we just calculated there, it is 21,385. Now we have to minus that from 60. We have to minus that from 60. Then we get our angle. From here to where the cardinal point is, it is 38,614. Then this angle from here to there, it is what? It is 30. When you add all of those angles, they must give you 90. It is 30 plus 21,385 plus 38,614 equals to 90. Like I said, they must give you 90. Now, this would be your east. This would be your north. Then you need to ask yourself, don't forget that this one, it is your resultant. Let's write it with the red pen. This would be your resultant. Now, the direction, it will be east because the principle says start with the cardinal point closest to your vector first, then the angle of deviation. The cardinal close to my resultant, it is 38. It is east, and it is the angle of deviation, it is 38,614 degrees north. Or if you start with north as your reference point, then your answer would be 30 plus 21,385. Then it is 51. It will be 51,385 degrees east. If you make north the reference point or east the reference point, they will not penalize you. They will give you full marks. Don't forget that when you add this and that, they must give you what? 90, because they occurred within the first quad. Now let's use the vector method. The vector method, we are having this one going south. It is VA, and it is what? 280. Is it 280? Let's double check. It is 280, yes. It is 280. It is 280 kilometers per hour. Then the VP was heading, then we stopped and reversed. It is now the opposite direction. VP equals to 600 kilometers per hour. This would be your 90, 0, 180, 270, then 360. Revolution is completed. In using the resolving method or the vertical or the vector method, we are looking for the magnitude of your vector and its position. We'll start from 0. The angle here, it is 60, then that's your 30. We start from 0, we look for those vectors. 0, boom, we found our first vector. The magnitude of your vector, it is 600. Its position, it is sine 60 plus. We start all over again from 0, we look for another one. 90, 180, 270. The magnitude, it is 280 sine 270. Then we calculate the vertical component. Then the horizontal component, where the sine we put cos, it will be 600 cos 60 plus 280 cos 270. Right. Now for vertical component, we are having 600 sine 60 plus 280 sine 270. You put it as it is, good people, to make your life easy. Just write everything as it is. It is 239,615 kilometers per hour. Then the horizontal component, where the sine we put cos, it will be 600 multiplied by cos 60 plus 280 multiplied by cos 270. Then I get my answer as 300 kilometers per hour. Then the resultant would be VC squared plus HC squared, all square root. Then I'm having 239,615 squared plus 300 squared, all square root. Now it will be up to you which method do you want to use. Preferably use the resolving method. Use this vector method. It will make your life easy. The answer that we got, it is 383,947 kilometers per hour. It's exactly the same answer as the one that we got when we were using the cosine method. Then when coming to direction, the coefficient of your components will indicate for you where your resultant is. We know that all forces going up positive, east positive, south negative, west negative. Now the coefficients here are positive. It then means my resultant is on the first quad. We didn't violate any principle. We still have head to head, tail to tail. Didn't violate any principle. Then whether you calculate alpha or theta, your answer would be the same. Now in this case, I will be calculating theta using tan. It will be the inverse of tan. Now the vertical component is 239,615 divided by 300. Then I get my answer as 239,615 divided by 300. Then I get my angle as 38,615 degrees. Then it will be east 38,615 degrees north, because it is from east to where the resultant is. Then north would be minus this from 90, then it will be north 51, like we got this side, 51,385. 385 degrees east. This is how you tackle those two questions, the projectile and this relative motion, good people. Thank you, good people.